Hi everyone, thanks for taking the time to join me today. Thanks to the organizers for making this event possible, because I think that building sustainability and energy efficiency is one of the most significant and accessible ways that we have to directly address climate change solutions. And specifically, I want to talk to you today about how life cycle assessment is an increasingly important method and tool that can not only be used to assess the environmental and economic performance of buildings, but also to help guide where changes to buildings may be the most appropriate to address and help the industry move forward. So life cycle assessment as an international standard is a relatively new addition to the environmental impact assessment toolbox. So early on, environmental impacts were largely dealt with by simply reducing pollutant amounts and then later looking at ways to prevent pollution or use less energy. But this lacked a bigger picture perspective about how ecosystem dynamics work. Or simply they transferred environmental issues from one area to another. So for example, compact fluorescent bulbs, which were widely used in the economy and promoted because they consume 75% less electricity. But the unspoken trade-off was they contained harmful mercury gases. So in essence, life cycle assessment was developed to try and avoid these types of environmental problem shifting, or greenwashing, as is often used by some advocates. So a great example of unintended consequences is the greenhouse gas emission trends we see with building construction in Canada over the last several years. So between 2014 and 2018, buildings contributed nearly 12% more emissions than they did a few years ago. So this means that despite using certified forest products or sustainable lumber practices or other technological advances, buildings are producing more greenhouse gases. And it's largely due to these large housing booms we see in large cities that have condos and townhouses that are being built to this minimum performance standard. We know there are emerging building codes that are likely to push builders to adapt, but for the builder, they need to know how can they maximize performance but still maintain that bottom line? You know, should you focus on green technology? Should I simply insulate and wrap tighter? This is where I think a life cycle perspective can help make those decisions easier. So when we look at the construction industry, it's traditionally focused just on the environmental impacts around materials used in construction and the construction process itself. There's been some attention paid to site preparation, especially if you're dealing with older trees or environmentally sensitive areas, but not in the context of minimizing soil and tree root disturbance. So only recently are we really starting to understand ongoing operation impacts, and there's almost no discussion about what those impacts are when a building no longer is serviceable. You know, what's the end use impacts of these buildings? And this is really important to consider because we want to approach a real net zero home build. It needs to consider the whole supply chain. And it needs to include estimates of how the building and how long that building is going to last too. So to quickly touch on net zero standards, what we know is that the majority of our current, or at least based on the majority of our current building designs, most of the emissions of buildings are going to be ongoing. So even if you use the most sustainable building materials available, after 100 years of operations, the emission savings from materials and construction decisions are slowly overshadowed by these cumulative emissions associated with the operations of that building. Because if we do a quick calculation of what it would look like at a national level, we would see that a net zero performance standard alone could save Canada about 30 megatons of carbon by 2050. It could easily double with retrofits, and just imagine what those savings could be like from a life cycle perspective if we started to include minimizing impacts for things like end use, the materials used, site preparation. So reducing impacts at every life cycle stage can have a real meaningful impact. So in that context, what I really want to talk about right now is a really interesting research project that I've had the opportunity to be involved with over the last year and a half. And that is about a life cycle assessment building project that I partnered with Ferris Build Tech on. It's a small home project that was built using minimal heavy equipment. A skid steer was shaved off a few feet of soil. That was about all we used. The rest was assembled by hand. It uses primarily only two building materials, EPS and steel. The EPS provides insulation, a vapor barrier, and it's the structure, which is really important. The steel is there primarily as the structure, but it doesn't penetrate the wall, so there's no thermal bridging. So the walls, the floor, and the roof end up being assembled as these modular pieces that weigh about a third the weight of a wood frame of the same dimensions. And the result of this reduced thermal bridging is really significant. So based on early thermal tests, the ferrous walls were 80% more efficient than their wood frame counterparts, even though they were a third the weight. They were stronger than the wood based on load tests, and they passed the 1-hour fire test used by ferrous because the EPS that they used won't hold a flame. But one of the things we also want to look at isn't just these thermal performances that might be associated with just a net zero. We also want to look at what are the other life cycle considerations when it comes to maximizing or minimizing impacts and emissions over the life of that building. So in addition to the thermal performance, there's a host of other performance metrics we think are realized with this type of building technology. So some of the things that, in addition to the exceptional thermal performance, is we think the risk of mold and mildew is mitigated. It doesn't hold the moisture like wood does. It's insect and pest and rodent resistant. There's, because of that mold resistance, there's improved indoor air quality. The EPS is also cured off-site, so there's none of that curing you associate with the spray and foam. The minimal site disturbance, we talked about the reduced equipment we use, but we'll talk a bit more about that. The components, the steel and EPS, it's 100% recyclable. So think about that end use impacts. We can now take that and turn it into something else. When we look at the CAD manufacturing process for this type of technology, in the build that we were looking at St. Lawrence College, we would come away with basically a small shopping bag of waste for a 600 square foot building. The expected life cycle of EPS is long, with some 500 years in landfills. So we expect that compared to traditional builds, that these are going to last at least twice as long. And we think that there's a really important aspect about climate change resiliency, things that can withstand floods and hurricanes and fire and mold and pests. And this technology is really interesting. So when we finish the LCA, hopefully this June, I think these are really interesting results to look at. One of the things I want to quickly talk about in terms of minimal site disturbance is that the impact to trees. So I also sit on the executive board of the Ontario Woodlot Association and do a lot of research with trees and urban trees. And the first thing I understand is that urban trees are stressed, and they're stressed from things like air pollution, but they're also stressed from things like basically access to nutrients. As soon as we cover them up with pavement and concrete, we reduce the infiltration capacity of the rain. That limits the water and nutrients that can travel to the roots. So you can see how these trees in this picture here, they have sparse foliage, lots of long, thin, spindly roots, and they're really stressed. They have limited access to water. So one of the interesting foundations we use with the Ferrets project is a product called Ecoraster. It's a plastic modular soil insert at the surface, goes down a few inches, needs minimal excavation. And the result is this little pad that we can use, that we use minimal fossil fuels to create. The water can flow both horizontally and vertically through the foundation. And this is a really interesting thing that can be used for the lightweight design of Ferris's walls. So some of the takeaways from today, I hope that sticks with everyone, is that by using LCA, it can help us understand how to make a building more efficient, how to make it last longer, and have minimal impact on existing sites. So other assessments, usually we focus on one or a few steps, and we need to be focusing on all of them. The second thing is we need to sort of, as we shift this paradigm about how we build things, we need government and public support. LCAs can be a tool to help facilitate those discussions more objectively. The third is that I really want to emphasize there's no single appropriate way to build a sustainable building. There's lots of different ways, and we need to start telling people that, because LCA is a way that we can start to compare apples to oranges to strawberries when it comes to different building techniques and their performances. And we know there are important environmental impacts other than energy and carbon, indoor air quality. These are all things that we need to include, because if they're not included in just a single net zero approach, it misses those other impacts. And so speaking of other impacts, just to sort of finish on a fun little story about what other scientists are doing to sort of push the sustainable development further, the envelope further. In the top right, you can see insects in the warmer months that are attracted to artificial light. What we're starting to find out is that up to 75% of insects near waterways and rivers that these buildings are next to can emerge at night, and that leaves our rivers and lakes with a lot less insects for the fish to eat. So it reduces the productivity of our waterways. There's also evidence that it keeps other animals away, like bats. Nearby flowers, if you have a garden planted nearby, 30 to 40% less flowers because of this nighttime light. So this is really significant things that we're starting to think about. At the bottom right, you'll see a bunch of colored boxes. This is from what's called the Ecolite project of the UK. They've been doing all sorts of really fun lights on fun tests on plants and animals. What they found is that red light is quite innocuous, kind of like that little red light setting you see on your camping headlamp. So that little picture here I have is from a pathway in a park in the Netherlands where they've started deploying these red lights. And so this is the other red light district in the Netherlands. So I want to thank everyone for listening in and thank the partners that I've been working with right now that have helped inform some of the content of this presentation. If you want to get a hold of me, my email is there, nathanmanion@gmail.com, all lowercase. I also have a link to my company's website if anyone is interested in exploring some of these sustainability solutions further. I'm always happy to start chat and new conversations, and look forward to hopefully connecting with you soon through some questions. Thank you.